All right, students in the 280 class, Security Plus certification material. All right, so we've got this, we ran into this cracking password with rainbow tables exam lab, and even though the lab itself is not horribly difficult to run through, sometimes it's hard to understand what it is we're doing on this. So I'm going to try to make an attempt to explain it here. I'm going to bring up some slides that I've developed in the last couple of days, and let's see, we're going to see if we can make some sense out of this. There's some repetitive information in the slides. I put that in there intentionally, and then we're going to go and we're actually going to work this lab here, try to relate the two together. So, all right, so rainbow tables and you. All right, so this is presented by Mr. Knight, or the Network Knight, as some may know me. All right, so you've got the rainbow tables and rainbow crack. All right, so what we're going to go over here, what rainbow tables are, how rainbow crack tools work, and the safe usage of them. We'll even talk some ethics, and we're going to talk about these specific commands, and we're going to use these in our lab that you may have already worked at this point with a MD5 and a SHA-1 example. So what is a rainbow table? All right, so that was it's a pre-computed mapping of plain text. So it's just a and you know, there's various rainbow tables that they pre-exist, right? So when these are already the same place you download the tools, you also download the actual rainbow tables. So the rainbow tables consist of text that's hashed in either, in its various ways. The text exists in lowercase, uppercase, numbers, special characters, that kind of thing. So the purpose of this is to be able to, if you get a hold of a password file from a system, you should be able to run the password file against the rainbow table in order to determine, to identify any passwords that may be visible inside the, that you may be able to pull from the password file. So what the rainbow table does for you, it shortens the amount of time it takes to do this, but it increases the amount of storage, so at pre-computation time. So rainbow tables themselves take up a lot of storage, and the output from them can take up a lot of storage too, depending on how big the password file is. And then it works well against unsalted hashes. If it's salted, it's ineffective. So it's a fast lookup for common short passwords if you already have the table. It's useful for controlled password auditing labs and historical research. So if you're a system administrator and you're auditing to see if the passwords that are being used by your computer users are compliant with your password rules, this would be a good way to do that. And then it will repeat here, it's not effective against salted or slow KDF stored passwords. So it's got some specific examples listed there. Bcrypt Argon 2. So here's an example here. We're going to give these a shot. This is basically from the lab. So I'm going to try to break down. This is a simple breakdown of what each item means here. We're going to, in the parameters, mean. So we've got the command rtgen. That is the command to use the rainbow tool, rainbow table tool to generate. And then, but our MD5 is our hash algorithm. So the ASCII 32 through 95, that is our character set. 1 to 20, 1 space 20 is our minimum to maximum plain text length. So we're only looking at the characters in chunks of 20. And the remaining numbers in the chain they include. So that starts at 0. It's the chain length, the number of chains, and the table partitioning. All right, we're going to go over those in a little bit deeper in a minute. So the way it works, you start by you sort the generated tables with sort, and then you crack. So that after you run the rtgen, then you sort it, and then you crack as many hashes as you have. So, and they use the rcrack for that, running this command. And then to crack a single hash, you can do it just with a single value. Now this slide I added to actually asked ChatGPT to generate this image here. So it sort of shows you how when you have these different chains, once you run through, how it kind of works through and reduces each time with the hash until you get to the end. So you'll see the path there, the plain text to hash to reduction to plain text. So only the start and the end are stored in the table. During the cracking, the target hash is reduced repeatedly and searched against end values. Matches reveal the corresponding start. Chain is regenerated to find the original plain text. So it just keeps running through this process. That's why until it gets to the end. That's why it's so CPU intensive. So limitations to rainbow tables. So rainbow tables only target unsalted hashes and specific hash algorithms. So salting, like you would find in bcrypt script and Argon 2, they mitigate the ability to use a rainbow table. And then GPU accelerated cracking are common alternatives for authorized testing. So GPU, using an actual graphics processor in a computer to handle the processing, can help speed this up. There's some ethical considerations here to use the rainbow tables. So you always want to make sure that if you're using rainbow tables that you have permission to do so. Written permission would be so essentially you shouldn't be doing this on a system that you don't have authorization over or in a lab environment. You can generate your own hashes, you can build a small table, and you can test the workflow locally. And then the next steps, you compare the rainbow crack versus hashcat and learn about salting and Argon 2. So those are things that you should learn as well, to learn some tools to help you with situations where a rainbow table will not work. All right, so let's break down this command here again. I did it slightly before, but let's just look at it. So this is our command here. rtgen md5 ASCII-32-95 1 space 20 space 0 space 1000 space 1000 space 0. All right, so rtgen, it generates the rainbow crack rainbow tables for fast hash reversal. It pre-computes chains of plain text and hash and reduces plain text. It trades storage and pre-computation time for faster crack time lookups, and it's best for unsalted hashes. All right, so we'll keep repeating that. Here's our command. It breaks it down. So see the command at the top, and then it break down at the bottom. So rtgen there. And then you've got the hash type, which is MD5 in our case. The character set or the char set is our ASCII-32-95. The minimum 1 and the maximum 20. Our table index is 0. Right, that's the first this 0 here. So we made it to our table index. 1000 is our chain length, and 1000 is our chain number, and then we've got our part index. So break it down even further for you. I just explained it on the screen, but this breaks each parameter down for you here and what they mean. This slide isn't very valuable. It meant something to me, but I can't explain it to make sense to I can't explain it well. So here's another going in a little bit more detail about chain length and chain count. So it determines coverage and collision rate, and then the longer chains, the fewer chains needed, but higher collision risk, and shorter chains, larger tables. So it just depends on which way you want to go with it. And then table size estimated depends on endpoint storage and index. Larger char sets and length ranges increase space exponentially. So if you got a large char set, then you could be using a lot of space. And then it's recommended to start with constrained char sets length for targeted password sets. So lower alpha, so the lowercase alpha 1 through 8 is one of the char sets. And this is the workflow of how these work, and we're going to work through this when we just do the example. But you create the RT files, and then you sort the RT files with rtsort, and then you end with the rcrack. I'm not sure why not rtcrack, just to keep it consistent, but it's not. So, and then you keep multiple tables and parts for parallel generation. So, tip for that. So that's the explanations on those. You could go through and view that independently, slowly, if it helps. So let's go through, and I'll try to correlate some of this as we're doing this here. I'm going to start this. All right, so note what we're doing here. So a recent breach of popular third-party service has exposed a password database. The security team is evaluating the risk of the exposed passwords for the company. The password hashes are saved in the root user's home directory. You want to attempt to hack these passwords using a rainbow table. The password requirement for your company is as follows. So what we're doing in this lab, and what we would be doing if we were the IT person at this place, we're trying to see if this password database being apprehended, how much at risk we actually are by checking out our vulnerable passwords. So, all right, so we're going to click here to start our command prompt. We're going to get started with rtgen. But we're also, before we do that, let's just take a look. A couple of things you can do once you're in Linux. In order to understand what directory you're in currently, you can do a present working directory command, right? And if you want to see what's in that directory content, you can do a ls to show you the files. We'll see our captured _hashes.txt file there. So one we're working with for now, or we will be working with. So now that we see that, we're going to do our rtgen command. It's a rtgen followed by a period, or not followed by a period, sorry. MD5, because that is the one of the algorithms, and we're using the ASCII char set, character set, and the actual file 3295. Then we're entering our other parameters, and I'll read those out to you here. So we got our hash, then our char set, then our minimum and our maximum. We got our table index, then we've got our chain length 1000, our chain number 1000, and our part index 0. So I'm going to enter there, we're going to run that. We're going to do the same thing and that runs through and creates, finds the data that's in that char set, which you can see listed here. All right, so now we're going to run the rtgen command against that char set for the SHA1 or SHA1. Right, generates that. Once we get to that point, we're going to sort the rainbow table because that's the order of the commands you saw earlier in our slide. Let me show you that. You see the order. So we've done the generation or creating the files. Now we're going to sort the files. So we're going to do rtsort space period. Yeah. It shows that it sorted the data. All right. Now we're going to run the rcrack against our captured .hashes. So we've got things set up now in order to use the. So basically, we're like this would be like, since this is command line, it's kind of hard to see. But what we've done so far is we've spun up to use that ASCII file, which is our rainbow table, our char set. That's part of the rainbow crack process. So we ran it against. So we got it ginned up for MD5 and SHA5. Then we've sorted it. Now we're going to actually run the crack using that against our captured file. Right, so here we go with the rcrack, and be careful it's not rtcrack. Seems like an opportunity missed there. Period. Right, so the value we have to use the -h here, or -l, sorry. And then we're going to go to the path. To the actual file. Oops, like I misspelled captured. All right, you see it actually we can see our passwords revealed here. It lists the hashes, and it also shows in the hash file, it also shows the password. So we probably have something to do with these. So if we wanted to take this further, we could take that, copy it, right? And we could run the rcrack against it directly. Rcrack -h. Oh, hold on. Against that. And it actually shows us individually that that password there. It's a little easier to see. All right, and we could do the same thing for this one. Matter of fact, I'm going to do it this way. I'm going to alright, so Mary had a small lamb. And you can do it against where'd it go? It's this one too, so I'm just going to go ahead and go up, get that out of the way there. Disneyland. Alright, so I'm going to answer these questions here. So the long one there was Disneyland 3. This one up here is, we saw that one's easy to remember. 1, 2, 3. For some reason copying and pasting makes that duplicate. And if you compare these to all these different password requirements over here, there's only one of these that meets all of these requirements. So we're going to check our answers here. I'm going to get 100% because we ran all the things. Alright, once again, this is Mr. Knight. In some circles, the Network Knight. Hope this helps. Thanks.